Human indoor localization systems facilitate various applications, such as indoor navigation, assisted living, healthcare, and smart home. However, many of these systems require too much effort to install or require each user to wear a device 24/7. We present TomoID, an easy-to-install, real-time, device-free, RFID-based tomography approach that uses radio waves to localize users within a living space. Only 3 components are needed: a reader, antennas, and RFID tags. First, we place an antenna on each wall, connected to an RFID reader in the room. Then, we arrange RFID tags around the room with the help of a cardboard template, resulting in one continuous line of tags around the space. Instrumenting a 300 square foot room took less than 10 minutes. As a result, our room is now filled with RFID signals that the human body interferes with. By identifying the changes in RF signals, we can calculate 3 tomograms out of RSSI, RF phase, and read rate individually. A UNet is then being deployed to inference a real-time probability map of humans' presence based on these tomograms. The user's locations are extracted from the center of each blob and smoothed by a Kalman filter. We evaluated the performance of our system by comparing the localization result against the ultra-wideband ground truth. TomoID only needs 5 minutes of training data to achieve a 19 cm average error with a single user at a refresh rate of 1 second per frame. Our system does not need the tracker to operate, but was included earlier as a comparison. As you can see, our system continues to operate without the ultra-wideband hat. RF is sensitive to micro changes in the environment that creates multipath. However, our system is robust to list noise, even when the environment is changing, such as moving around furniture. TomoID is able to locate users with different heights and weights as well, without adding them into the training data. We also evaluated our system for tracking multiple users. We found an average error of 39 cm while tracking 2 people, allowing us to perform multi-user, device-free localization while still retaining reasonable accuracy. Without recording data in new environments to train the model, we tested TomoID in 2 more complex spaces. Here we show the system operates in the fabrication lab. That can be used to track the usage of the space. And seeing through walls into a hallway that can perform access control or traffic monitoring. In the future, we envision our system to be embedded in drywalls or pre-made in wallpapers for even faster deployment. For more details, please refer to our paper.